SoHHytec. Solar fuel, the smarter way.
We have podcast episodes. This time we are in Lausanne and we are recording at the EPFL campus where the SoHHytec premises are located. And I'm here today with Saurabh Tembhurne, the CEO of SoHHytec. And this time we are going to have this conversation in person in order to also show their technology, which is standing right behind. And we will have a chance for Saurabh to explain more in detail about the technology. So thank you very much, Saurabh, again for joining us on the podcast and also for sharing some more insights of the technology.
Definitely. Firstly, thanks, Aurora, for taking the time and having me again.
So last time you tried to explain a little bit the technology, but since we are here, can you also, explain it once again, the concept of your technology and as well the products range of that SoHHytec has developed so far?
So for sure, with pleasure. So let me set the ground here. So essentially, what you see behind us is our ARB. So basically, it's like an artificial tree. The concept is quite similar to what basically real trees do. So it's the process of artificial photosynthesis. In technical terms, basically photoelectrochemistry. So basically, we collect the light, concentrate that light, and using that sunlight, we directly break the water into basically hydrogen stream, oxygen stream, as well as heat being one of the outputs. So this is what you see at the back. What you see is a big parabolic reflector that collects the light, concentrates that light by a factor of 1000. We pump water up to the main reactor. That's the heart of the entire solution. And that's where basically the water is directly broken with the sunlight which is being concentrated.
Okay, so this is the biggest size, or what size is this? And since we are here, can you also explain all the sizes of the ARC that SoHHytec has developed, as well as would be good if you could also give us some figures on efficiency, cost, prices, and cost reduction compared to other technologies out there that produce hydrogen or the same kind of products from the solar light.
Sure. To answer your first question, no, this is not the only size, and this is definitely not the biggest. In fact, it's one of the smallest one.
Okay.
So in our product range, we have three sizes which we are basically deploying. And again, the idea is to cater to diverse scale of use cases. So really small to mid-scale industrial use cases all the way to large-scale use cases. So this is a 7-meter diameter arc, what you see basically behind us. But for the product ranges, we have 9-meter diameter, 13-meter diameter, and 25-meter diameter.
Okay.
And then to comment very briefly on the technical performance and cost aspects, just to put it into perspective, the alternative of what we do could potentially be you could install big PV farms, conventional photovoltaic panels, basically connect them to something called electrolyzers. So our efficiencies basically are almost 2 to 2.5 times higher than whatever best PV plus electrolysis solution you may find out there. That helps us basically definitely in reducing the cost of production of hydrogen. But also this has another key benefit that in a given land we can produce at least 2 times to 2 to 3 times higher. Basically, that is also a very crucial point basically. So yes, 2 times higher efficiency, at least 2 to 3 times better production, and the cost wise we can be 30 to 60% cheaper than any other alternative.
Okay, so would you say that one of the key advantages over competitors is the efficiency rate of your technology?
So yes.
And sorry, and how do you see your technology impacting the hydrogen industry on a broader scale? Let's say you mentioned this size and this is one, but I imagine fields
Correct.
of lands filled with this kind of technology in different sizes, and what would be in that case the impact on the hydrogen um, industry?
Exactly. So let me take the second question first. So as you correctly said, the way basically we deploy on a bigger scale is you can literally imagine garden of arbs, multiple of this. A garden could be 25, 50, 100. So this is really for small to mid scale use case, all the way to really farms and forest of multiple of these arbs. So if I now go back on the hydrogen market, so today the main challenge, by the way, is that most of that hydrogen is produced using non-renewable resources. And of course, there are renewable alternatives like the one which I just mentioned. You could use PV farms, connect them with electrolyzers. So renewable electricity powered electrolysis is one renewable way basically to produce hydrogen. But with this approach, you still have a lot of challenges. Basically, cost is still one of the key things. The hydrogen produced with this approach is still multiple times expensive than the so-called gray hydrogen, which is coming from fossil fuels, basically. And this is all related to inefficiencies in the entire chain, right? Because you're producing electricity somewhere, transmitting it, so there is loss. You have to use power electronics to convert, and then you feed it into an electrolyzer. So a lot of losses are there. And in our system, we do it in kind of one step. So sunlight goes in and we directly break that water in one single step. So we do something called photoelectrolysis. So efficiencies are much high. Yes, that's one of the key USPs, which allow us to be basically even cheaper than any other competing solution, but also potentially cheaper than the gray hydrogen prices, depending on the use case. And that is quite interesting because we can literally disrupt the existing gray hydrogen market by being not only green, but also being cheaper than the conventional fossil fuel based hydrogen.
Do you have a percentage of this, the difference between the price that you offer with your technology compared to the gray hydrogen or these other examples that you mentioned? What would you say is the difference in percentage of the price?
Correct. So to compare it with alternative solution, again, photovoltaic plus electrolysis, it's a bit simple. There I can really highlight the percentage. So depending on the location, because sunlight and other parameters are different, we can be 30% all the way to even 60% cheaper than this alternative. Compared to the gray hydrogen price, it's a bit slightly difficult question to answer, because depending on who is the end user, what is the scale, which geography you are, the gray hydrogen market prices are different.
Okay.
And depending on how you operate and deploy our solution, our production price would also be different. But definitely at a particular scale, we can be similar, or let's say again 20 to 30% cheaper than even the gray hydrogen market prices. But yeah, a lot of parameters are involved.
Okay. Staying at the advantages, or how eco-friendly is your technology compared to also other technologies out there? Is this also something that makes you stand out compared to other technologies in the market?
Definitely. In fact, it's one of the, let's say, other soft benefits of the solution. Of course, we use direct sunlight, break it in a direct way to produce hydrogen. So the operational side is fully sustainable. That's quite clear. But it's not only about operational sustainability or eco-friendliness. It's also about which materials we use. Can you recycle the solution? So what is the entire CO2 emission from cradle to gray approach, right? So in fact, we have done detailed studies, compare our solution with all the other approaches, and in terms of so-called CO2 intensity, we are one of the lowest out there from a cradle to grave approach. Also, if I give you a simple example of recyclability, you may have seen big solar photovoltaic farms being installed. The farms which are reaching end of the life, now actually it's a big problem. How do you recycle those silicon solar panels? They cannot be nicely recycled. Actually, people are dumping them, so that is a big problem. In our solution, this is not a problem at all, because what you see here is a lot of basically glass mirror as well as aluminum and steel. This is the biggest part of the structure. It's almost 100% recyclable, and a lot of components inside the reactor also are 99% or higher recyclable. So definitely we also have significant edge in terms of eco-friendliness compared to any other solution.
Oh, impressive. Is there a life cycle of your technology? What would you say is the approximate life cycle for, let's say, this size, or depending on the sizes?
Yeah, definitely. So the life cycle for sure is also again on the impressive side. So normally 25 to 30 years is the lifetime of the entire system. Of course, there are certain subcomponents being involved. Actually, in the entire system, there are only very few moving parts. You would see basically the system is following the sun, so that's the only moving part. But yes, for 25 to 30 years, you do not have to do any major maintenance replacement in the entire system, which is again very, very positive.
Impressive. That's great. Thank you for sharing, so people that listen to our podcast can get to more into details with your technology. As you know, there are many technologies out there, but we try to be very picky with what we choose to also show to our audience. But also, the partners of the Subspace Energy Hub are usually companies that have a proven record out there, or they're doing some really test-proof innovation. And this is the whole goal of the Subspace Energy Hub, to collaborate with such companies. So since we're here, what is something you're looking forward to when it comes to your collaboration with the Subspace Energy Hub? you know that our goal, as I said, is to pair companies like yours together with other stakeholders, which could be investors or could be clients or could be contractors, that would have an interest in doing this consortium, and we jointly set up a project idea, and we apply for funding sometimes, or we have industrial partners that do the funding, and then we jointly scale and also set up the project. So is there something you're looking forward to in with regards to the Subspace Energy Hub that you would like to bring up here or mention?
No, definitely. In fact, so our synergy with the Subspace Energy Hub, I see on basically three fronts. The first of that being, of course, Agarbag Test Gallery and the Subspace Energy Hub provides this nice platform to potentially study and demonstrate the use of hydrogen for underground infrastructure, potentially also studying how hydrogen can be stored in an underground way. You have other partners basically who are working on the different aspects of the entire value chain. We being on the production side, this helps us in a great way to basically not only showcase our solution there for such a use case, but also to collaborate with the key corporates which are being part of the hub and take it. First stage basically would be at the Subspace Energy Hub itself, but beyond that, really scale it and go towards the commercial use cases. And then, of course, beyond this key topic of collaboration, what you bring from the perspective of your network also helps us, because you are focusing on renewable energy aspects. We are in the same game. So basically, from the perspective of whether it's customers, partners, or even in connecting to the investment community, the network you bring forward is basically also very helpful for us in the stages we are in. So yeah.
I would also add that I see a good fit of SoHHytec in our project discussion with the DC microgrid workstream. We see incorporation of your technology also on this idea of having a self-sufficient construction site in terms of technology by interconnecting different technologies and solutions that would supply the construction site temporarily with the energy. And I think because your technology is very portable in a way, easy to be moved once the construction phase is finished, we are really looking into involving SoHHytec in this project idea. Also, I would add that we are very excited to have you on our panel discussion that is upcoming in June. So in June, we are organizing this panel discussion on hydrogen storage underground, and we are gathering different stakeholders of the industry operating in the hydrogen industry on a talk about the challenges and advantages of the hydrogen storage underground. So Saurabh will be representing SoHHytec, and we are excited to have his insights on the panel this June. So we're really looking forward. So Ariel, you are the head of project development for SoHHytec, and you've been with SoHHytec for 2 years now, right?
Yes, correct.
What would you say are some of the challenges that currently the hydrogen industry is facing, and how is SoHHytec addressing them?
Sure. What we see for the green hydrogen industry is that there is a lot of interest. There is a lot of potential use case for green hydrogen, and there is already a lot of use case for gray hydrogen. It is a multi-billion-dollar business already today. And there are a lot of companies trying to transition in from gray to green, but there is a gap in price. So obviously there is a value in going from, let's say, gray to green hydrogen, but this value can only compensate up to a certain gap. So basically what we need to do to enhance this pace of adoption for green hydrogen is to reduce the green hydrogen price. And this is what we do at SoHHytec. We are bringing a more efficient technology to try to close that gap, and even in some situations we can be even cheaper than gray hydrogen.
And taking into account what you just said, like how you're addressing the challenges, how are you also scaling the SoHHytec technology and its potential applications in different industries?
Well, about the scaling is pretty straightforward. As you can see, our building block is the arc, which is a tree. So we simply replicate that concept. When we install dozens of these trees we install what we call gardens. And when we install hundreds and thousands of these trees, we install what we call forests. Then there are, let's say, central system that we design for specific building blocks, but then it's only copy and paste. So it's pretty straightforward. We don't need to develop a new concept for every project. It's only a replication of our core system.
Okay.
For the integration with other businesses and industries, the advantage of our system is that it's a co-generation system. It produces not only hydrogen but also electricity and heat.
Yeah.
So part of our value offering is to sit with the client and evaluate how we can integrate all the different outputs of our system to make a better use of the installation.
So basically, you customize your technology depending on the industry needs and what the client is asking for and in the amount they're asking for.
Yes and no. It's not that we customize. It's, let's say, our base concept is very flexible, so we don't need to customize it, but we evaluate how we can integrate, let's say, the streams in the client's process. For example, if they need a heating stream, we can use our heating output to, let's say, cool or preheat a stream of water, a stream of their raw materials, etc. Or for ambient heating, there is a lot of potential uses.
So besides that, what would you say it's next for SoHHytec, Saurabh? What are you looking forward in the upcoming months as the biggest next steps for your company in terms of collaborations, partnerships, projects, investors? What is it?
Yeah, so our key, let's say, next step, a significant one is basically our first industrial project is going to be live very soon. It's in advanced stages of completion, and within coming months, we would basically have the opportunity to officially, let's say, open that particular site. Beyond that one, we are already working on other projects with different sizes of our app, different scales, basically starting with Switzerland, but also let's say other parts of Europe, particularly Central and South is also our focus, where our pipeline projects are. So we have been a bit, let's say, fortunate in terms of receiving solid demand for our product. So now this is also basically the other part of the story to fill that project pipeline where we have significant projects in south of Europe, also India and US is also on our target list in terms of target geographies where we have pipeline projects. But now we have to boost up our resources to be able to cater to those projects. So that's where the second important things comes into picture. So we are basically going into manufacturing phase. So in the coming quarters, basically we would be stitching up our plans for creating our own manufacturing facility for the core photoelectrochemical reactor. And to do that, of course, we also need the support of other parties. So we collaborate extensively in this particular field. For other parts, definitely, we are also streamlining our supply chain, the network of our partners who can join us basically in the long-term journey to not only manufacture the other peripherals, but also to be able to support us in our value proposition to the end customer, where we are trying to offer really hydrogen as a solution or as a service rather than just simple equipment.
So thank you very much, Saurabh, for your time today and for sharing your insights and more details on the technology of the SoHHytec. And I wish you continued success with your next plans and also with our collaboration with the Subspace Energy.
Great, thanks for having me again, and thanks for basically taking the time to visit and allow me to actually visually show basically what we do. Looking forward to our collaboration.
Looking forward. Thank you very much. We have podcast episodes. This time we are in Lausanne and we are recording at the EPFL campus where the SoHHytec